turn in, but do not attach anything. Unless you are the group leader, then you attach like this one, group 6 assignment. Then I hope you do not put like this because I will deduct marks for additional assignment because you are not following the instruction, and it's difficult for me to check one by one if you all of you have turned in and then you attach something unrelated to your answer script. I only want to have your answer script. Only 11 attachment should be in this turn in folder. Okay. Clear? I hope this one clear. Let me go to our today's work. Mesh. All of you managed to do the, wow, mashallah, 16 turn in. Okay, let me see. Siapa? Who wants to volunteer? I will go for volunteer first. Anyone who wants to volunteer? We can discuss your answer. Anyone? Do not be shy because this is like, if I can mark your work, then you can learn something. You know better than your friends, right? So it's better for me to choose your paper if you volunteer. Yes.
3.8 saya boleh check madam, saya confused sikit awal-awal like how to get the IA, IBIC.
And this is siapa ni?
Afiq Zawawi.
Afiq, where's Afiq here?
Bawah sekali.
Bawah sekali.
No, yang submit.
Okay, let me see. Okay, bismillah. Right, this is 3.8, right? Afiq?
Yeah, madam.
Okay. Alright, for your mesh analysis, the first thing first, you need to draw the mesh, the imaginary current. Okay, Afiq answers there. And then Afiq also put the I1 and I2. Yes, very good. And in fact, you can follow this IA or IC, but I think it's better to put I1 and I2 because you will not confuse the IA here and IC there. But you need to point out lah, what is IA equal to? IA equal to I1, right? Because they are in same direction. And then I2 is equal to this, better put IC here. IC is equal to I2 minus, right? A negative sign because this is going to this way, but IC is this way. So it should be opposite direction. And then what is IB? I think, let me check your answer, Afiq. IB. Okay, Afiq, but it's better to write down. This is the last answer, but better for you to write down what is IB. So before coming to that conclusion, you write down what is IB. So moving through 45 ohms. This is 45 ohms. And IB is, this 45 ohms is sharing in between two loops, right? So what should you do? Okay, let me change the color. I2 is moving this direction. This is I2. And I1 is moving this direction. So IB is basically equal to what? What do you think? IB is equal to, sekejap, ada orang nak masuk. Ramai lagi. Ramai. Okay. Sekejap, saya kena kecilkan ni. Kalau tak, future student yang nak just come in will not enter the classroom if we have something else presented here, presenting. So IB is equal to the same direction. Okay. IB is equal to the same current direction of this IB, which is I1, right? Minus with the opposite direction. So you have this I1 minus I2 equal to IB. I1 minus I2 equal to IB. But if you confused, you don't understand what I mean by this. This is just my way to to do the thing, but it's actually the same. This is IB, right? And you know that I2 is going this way at this node, and I1 is going that way to the left side. So what you can do, you apply KCL at this node. So what is IB equal to? You just do the KCL, I2 equal to IB plus I1. So is it the same as this one? Is it equal?
No, madam.
No,
No.
I2 equals to IB minus I1 then equals
Oh, sekejap. Saya yang salah ke? Sekejap, saya tengok.
I1 minus IB.
Oh, ya Allah. This one, I2 is equal to I2 plus IB. Ya Allah. Nasib baik saya tanya korang. Now, is it same?
Yes.
Okay. Because why? This current I2 is entering the node and IB also entering the node. So entering should be equal to leaving the current, right? So IB plus I2 equal to I1. This is what we mean from our KCL at this node. And then for IB here, it's actually only the same direction minus with opposite direction equal to the IB flowing through this 45 ohms. Depends on you which one you like, and then you can use that thing. All right, that's number one. And then number two, you need to figure out for mesh analysis, do you have a super mesh? What is a super mesh? You need to find out the current source, right? Current source in between two loops, two closed loop. So if you have that, since we don't have that in our example here, so we can ignore that. But if we do have, then you should draw the boundary of two loops that shares with this current. So since we don't have, then we ignore that part first. And then the next step is to build up KVL. This is good. Very good, Afiq. And what should you do? You do the KVL at the loop 1 and 2. So if you look at here, Afiq start from 40, yes. And then 3, I1. And then 45 here. 45, kejap. Afiq, this is not 45, right? This is 3. 3. Oh, yeah, betul. 45 here. Astaghfirullahaladzim. 45 and shares between 1 and 2 loops. So I1 minus I2 because we concentrate on the first loop first, which is the I1, and minus with the opposite. So this is good. And then plus with 2. So this equation is correct. And then KVL at the second loop is the negative 64 here and plus 1.5 with this I2 and 45 here. Since we concentrate on this loop first, so I2 should be minus with the opposite, then this is correct. And plus for I2. Yeah, correct. So you will get like, this is 1.5, this is 1.5. And the figure here will give you also 1.5. I will look at the current, imaginary current inside the loops and also the name you name, like I1 and I2. And you don't have the nodal reference point because nodal analysis you need to use reference point, right? So I know that you are using mesh to solve this problem. Okay, for this part, I don't have the answer, but if you do it correctly, you will get the correct answer. Okay, let's compare with other brothers and sisters. Do you have the same answer as Afiq? 48 and 52? Or not? If not, then we
No, madam, not
no,
same.
not
No,
same.
madam,
Maybe
not same.
there's something 3, 4, 5 betul, 50 betul, minus 45. This is correct, right? Anyone? The first loop.
Yes, equation betul. Equation
Okay.
betul.
For the second one?
Betul tak?
Betul juga.
Maybe
Okay.
bila saya buat dalam calculator salah.
Yeah, maybe your calculation. All right. And then when you get this, you apply this part, you will get the answer. And remember, IC ni kena opposite kan. You need to inverse the I2 for IC. IC. Okay. Alright, maybe this is wrong. So this also will be wrong. Okay, nanti check balik Okay, save. I will return this. Okay, any other volunteer?
Me, madam.
Apa? Siapa tu?
Amirul Muslim.
Amirul. Amirul. Where's Amirul's answer? For question number 3.9. Good. .9, right? Yeah. Do you get the same answer as Amirul for 3.8?
Yes. Sama madam.
Majority of all,
Dapat.
descendants. Okay. Okay. So this one should be a negative. So for IC, and this part should be 9.8. 9.8 minus. Is this correct? IB? If it is a minus, then it should be correct lah. Do you get the same answer for IB? Negative 0.2. Brothers and sisters? Kau lain? Betul tak? Plus minus 10. You're supposed to get the same. Okay. Kenapa semua diam? Do you have problem with IB? Brothers and sisters?
Sedikit.
Huh?
Sedikit ada problem.
Ada okay. Alright. Check balik.
Nak check balik.
Maybe you confuse how to get the IB, right? You need to apply KCL je sebenarnya. Alright. Okay. Let's look at 3.9. Okay. If by looking at Amirul's answer, straight away we know that Amirul's is using the mesh analysis. Very good, because Amirul used this sign, the imaginary current with I1 and I2 there labeled. Okay, then next, do Amirul have super mesh here? Yes, right. It seems like Amirul is drawing some boundary there. Tapi kalau if you have highlighter, it's better to use that, because kalau macam ni pun I can accept, because you are doing something like this, right? Outside. So this is a super mesh. And then sometimes if you don't put the drawing like this, I will look at the word here, super mesh. Okay, good. And next, when you have a super mesh, you have to apply two things, KVL and KCL. Okay, good. And then you have the first one, KCL. It's supposed to have the same direction of this current, which is I2 minus with the opposite equal to the 3, right? So this is correct. And then KVL at super mesh. This is the boundary, the outer loops here. So start from Amirul start from 18 here. So this is negative 18 betul. 3 I1 yes. Then 9 I2 yes. Minus betul. Minus 15 and then plus 2 I2, yes, and then plus 6I1. Yeah, this is correct. So this is 1.5, this is also 1.5, this is also 1.5. Good. And then use your calculator, you will get these two answer. Anyone who get same answer as Amirul?
Same, madam.
All of you agree?
Agree, madam.
Allah. Pecah dah. Tak apa, tak apa. Buku jatuh, kena benda. Okay, and then power. Power, how do you get power equal to 33? Ni sudah. This one is by looking at your I1 and I2, what is I1 equal to? 0, right? So if 0, then you know straight away at this part, this I1 here, this component, this element and this element, all of them will have power equal to 0. But what left? There's 4 elements in the circuit here. So what are they? This part, the 9 ohms, 15 volt, 2 ohms, and 3 amps. So these 4 you should have if you want to have power equal to 0. What I mean is all the active element should be plus with passive element should equal to 0. Power active plus power passive element should equal to 0. See here. Okay. And then but since the question asks you on the apa soalan? Soalan is on the power dissipated, right? Power dissipated means the power delivered means from your power source. So you have that if you follow Amirul's direction here, Amirul will have this current entering the 15 volt. So the negative 15 here. And remember power is equal to IV, right? So what is the current equal to? Amirul? Anyone?
3.
15? Yeah, 3. Okay, good. And then with this thing, this is it should plus here. And then because if you look at the 3 amps here, and these 3 amps, the current source here is actually in parallel with 18 volt when this one the power, there's no more power, right? When there's no more power, there's no voltage drop here across these 3 amps. So over here is like you don't have 3 ohms here, 3 ohms and also 6 ohm. So it's like you have 18 volt here in parallel with these 3 amps. So you can use the 18 volt here, which is equal to, if you look at the current direction of I2 here, it's actually going to here. So you have a minus 18 into 3 amps. Is it clear? And if you do the multiplication, you will have what? This is 15, 45, and this one? Berapa? 40, berapa ni? 54. Is it? And you have negative 99, betul tak?
Yes, madam.
Okay. And this is a power dissipated. The negative sign here shows that this is the power is delivered or power is dissipated. Okay, the dissipated sign.
Madam.
Right. Yes.
Tapi kat soalan tu cakap on each resistor, madam.
Each resistor. Sebenarnya what do you understand coming from?
Power kan each register lah.
They actually should say that power is absorbed at the resistor kan. Kalau power is delivered at jap. By nature, saya faham, saya rasa kenapa dia tulis macam tu, sebabnya when you have a resistor ataupun any load, when you attach it with some power supply, then katakanlah ada power supply like a battery, and then you have some load, and then when you use this device, you will, when you touch the thing, sometimes you feel some heat, right? When this is inactive, maksudnya the circuit is inactive, is in use. So you will feel some heat. It's like the heat is transferred out. So that's why power is dissipated. Tapi kalau you look at your theory part, from your slide chapter 2, you will have apa? Active element, power is delivered, right? And for your passive element, power is absorbed. Betul tak? Betul ke tidak? Ke saya mengconfusekan anda? Okay, tak apa. Tapi the thing is, you follow back the theory, tapi in terms of wording dia sebenarnya macam tu lah. Okay, tapi if you want to verify it with the resistor, then the resistor will take macam ni
Madam, excuse me.
Yeah. Okay.
Tapi kalau buat macam tu, macam kalau tak cari super mesh pun boleh je dapat jawapan kan?
Boleh. Yes, kan? This one just for you guys to to test your knowledge on mesh analysis. That's why I said, even any question, your circuit, you do have any circuit, and then you have some problem there, and you can solve whichever method that you have learned so far. Sebab tu saya kata, kalau you have like a group of 5 people in your group, so one of you can use maybe method number 1, another person will use method number 2, another the third method. So you can compare, the answer should leads the same answer. Faham tak? You can compare. So itulah. Okay. Ke tak faham tadi? Alright. Kalau awak tengok ni, let me remove this. I just want you guys to prove power is equal to 0. Let me use this one, and this is our ni lah, loops. So if you have this, and we start from 9, current is entering this 9 ohms, so you have a plus 9, and you know power is equal to I square R for resistor, right? So what is the current? 3 square. And then you have this negative 15. This is a plus, tapi I just put like this. And then the 3, and then plus 2 there. And then you have 3 square. And then you have 3 plus 3 here with the negative 18 volt. And then you will have apa? Summation of all power throughout this loop. You will have 0, right? Cuba kira, betul tak? And this one we know that we have this and this equal to negative 99. Okay, negative 99. And then plus with, this is 2 into 9. So you have 18. Plus 9981. So you will have 0 watt. Betul tak?
Betul, madam.
Okay. So this is to prove that all power should balance in one circuit. In fact, if you include the left side here, the circuit on your left side at this part, all this also on your left side here is multiplied by 0, so it should be equal to 0 lah. Okay, any question? Ke still confused ke? Question?
No, madam.
No, madam.
Okay. Alright. Who else want to volunteer the last question? Kita ada lagi like 10 minutes. Ada dua ni. Bagus. Or you want to proceed with Amirul's answer? Unfair, right? Okay, anyone? Cepat. Anyone? No? Then I just pick one. Siapa ya? Tengok ni. Okay, Amira. Amira up to 3.9. Okay. Who have done the last part? 3.10 and 3.11.
Empat ada.
Tak sempat. Okay, Amira je. Siapa lagi? Kalau tak kita tengok je Amira punya. Okay. Amira je. Okay. Alright. Okay, do we have any super mesh here? 3.10. No. No, because your target, you should look at your current source. So there's none. Okay, I think this question is straightforward. You just apply the rule. So this one should be negative 10, and then this one 10 in between I3 and I1. So I1 minus I3, yes. And then 3, I1 minus I2, yes. Minus 12, yes. For I1, yes. And then the second loops, you should have start from, okay, 12, 3, I2 minus I1 plus 12, I2 minus I1, and then 70, yes, and then 2, I2, yes, this is correct. This one also correct. And you have the last loop, 6, I3, and then 12, I3 minus I2, yes, and then 10, yeah, betul. Okay, for this answer saya tak tahu berapa jawapannya, tapi nampak cantik je, betul kot. Okay, okay, my concern is this one. Bagus Amirul, tunjuk ini. Okay, Amira ada all the current, imaginary current, yes, semua betul. And then let's look at how you get the answer. My concern is at this loop, I1. So let us see. Bagus. Okay. If you watch my mesh analysis video, I mentioned to you, if you have a current source at the outer loops like this, okay, it should not you should not build up equation around this loop. Okay, do not build up equation around the loop. Bagus. Amirul tak buat macam ni. So, what is this I1 equal to? I1 is equal to the current I1 is moving this side, right? Same direction as 1.5 milliamps here. So, you just take I1 equal to 1.5 milliamps. Don't forget the unit. So, this is correct. Kalau awak bagi yang dalam ni, saya akan buat pangkah terus. Dan saya akan tengok jawapan last tu semua salah. Okay. Yang the rest, yeah, it should be betul lah. Mesh 2, where's mesh 2? Okay, here. You have negative 3 I node, tapi questionnya adalah to find I node. Betul ke? To find I node. Where is I node? I node is at here. So, since I node is at here, and you know that I node is in opposite direction of I4. This is I4. So you should apply the equation dekat sini je. Then I will just look at your I4. So this is 8. 8 since we start from 8 volt here. Okay, 8 and then 4K. 4K of I4, yes, and 3K of I4 minus 1.5 milli. It's about the I1 is equal to this, okay. And then since you have only one unknown here, then straight away you can get the answer. Answer is this, kalau betul this one. Betul Amirul? Because inside here we have the milli, so milli and kilo should cross. Mungkin betul, nampak macam betul. And then you have the opposite direction. Okay, yeah, very good. Okay. Any question? Rasa betul, bagus Amirul. Ada siapa lagi who wants to volunteer? We have 5 minutes more. Tengok jawapan Afiq tadi. 3 I want maybe this one ni. Ada salah kira kot Afiq.
Yes, madam.
I think that's a wrong calculation sebab I1 supposed to be 0 and I2 is supposed to be 3M. So over here I2 minus I1 ni betul. This one minus 18 3I1 9 I2. Oh, okay. This is minus or plus?
Minus, madam.
Oh, you're supposed to follow the current direction. This
I
way,
see.
right? And then this is entering passive element. It should have
It should have been positive.
okay.
Okay, madam. I see.
Plus. Then this one also. This one going into this 2 ohms. 2 ohms is passive element. So you should have plus there. So ini je lah yang salah.
Okay, madam.
Okay. Okay, any other maybe question or you want me to check yours? Or yeah, anything? So which one you like? Mesh analysis or nodal?
Mesh madam.
Masya Allah. Yeah, majority said mesh in this group. The other group says nodal. Oh, bagus. Tak apa. Okay, then do you have any question besides this? Ada tak?
No, madam.
No madam.
Amira dah tanda untuk dia. Okay. Okay, with that I think can we conclude our class? We finish our class with tasbih kafarah and surah al-asr. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك. Alhamdulillah Rabbil Alamin. Okay, tak ada apa-apa Actually, I want to give you some poll on which one you like. Do you like to have a video first, a synchronized or asynchronized classroom? A flipped classroom or the normal one, the synchronized? Nanti I will give you the poll and then you vote lah. Kalau tak, we will do something like this. Else we will do like the normal class and then lecture and then you will see that I will do the calculation. Tak bestnya. Okay. All right, brothers and sisters, thank you so much.
Thank you madam.
Thank you madam.
Thank you.
Terima kasih madam.
And also take care because I know COVID is in
Madam.
Madam, thank
Okay.
you.
Thank you madam.
Madam.
Thank you madam.